Hi everyone, welcome back to my channel. In this video, we'll solve the following differential equation y prime plus 2xy is equal to 2x cube with the initial value condition y of 0 is equal to 1. So note that this is a first order linear ODE. Now first order linear ODE has the following form y prime plus px times y is equal to qx. So by comparing, we get here px is equal to 2x and qx is equal to 2x cube. Now we know the formula of integrating factor for first order linear ODE, which is given by e to the power integral px dx. Now what is px? Px is integral to xt. So by integrating we get x e power x square. So by multiplying by integrating factor x square both side of this equation number 1, we get ddx of y times ex square is equal to 2x cube e power x square. So y e power x square is nothing but 2x cube e power x square dx. Now let x square is equal to u. So we have 2x dx is equal to du. So this integral we can write it as x square e power x square times 2x dx. So it is u e power u du. Now we need to perform integration by parts. So by doing that, we get e power u minus derivative of u is 1 and integral of e power u is u du, which is nothing but e power u minus e power u plus c. Now what is u? U is nothing but x square. So we have x square e power x square minus e power x square plus c, which is y e power x square. So by simplifying, we get y is equal to x square minus 1 plus c times e power minus x square. Now we have the initial value condition y of 0 is equal to 1. So we put y of 0 is equal to 1. So we get y, so y is 1, x is 0, so 0 minus 1 plus c. So here c is 2. So we have the solution y is equal to x square minus 1 plus 2e minus x square.